Okay, I have some personal thoughts. As in the introduction it said, I come from a slightly different way, and I think my first introductory slide is a little bit about that. So originally, at least, I trained not as a computer scientist, as a computational science and computational engineering. So small difference, right? And then, like, this looks very linear here, but life is not linear. So I kind of didn't really know what to do with my life, and stuff happened in my life, and I ended up doing an internship in a lab in Paris when I finished. And there I fell in love with medical imaging, and I did some simulations of hearts and compared them to real life data of like MRIs of beating hearts. Then again, life happened, and I ended up in a bone lab as the only computational problem, and someone gave me a fox that died, was run over by a car, and a scalpel, and said, "Prepare this for the microscope." So I spent the next 5 years studying bones under the microscope and writing codes to do image processing for various kinds of bones and CT scans. And this is a polarized light microscopy. I can't remember what species it is. This is bone under the microscope. Okay, so then I didn't have a career. I wanted to stay in London. I didn't have opportunities to continue studying bones there, and so I became a research software engineer. So I kind of moved in between the image analyst and the research software engineer role. For the first 3 years, I got a variety of projects. I learned a lot. This is one of the major projects I did where I did a graphical user interface for planning ultrasound therapy. Cool. And so, kind of interestingly, to Agustin, I have a very similar. My analogy is not islands, my analogy is silos, and this is lifted from an abstract of Maria, who had also an amazing image. I emailed her whether she would send me the image that she had on her flash talk at I2K. And she also has this, like, the initial training of these people from these disparate fields. If we don't do this well, if we don't chart the routes between the islands, we will end up with bad communication. So this is kind of the ground thing that I use, the course that I use for teaching software to image analysts, but this is at a higher level of abstraction. So here, instead of, it's master students that do scientific and data intensive computing. So this could be an image analyst, right? Like we do biological imaging, biology is scientific, image analysis is data intensive, and involves computers. And I really like the materials. I will share the slides. You can click on here if you want to see the course. And so I was asked also to talk about what are the basics of good software. So once you've learned Python or R or something, this is a lot. So that's why I put a question mark at the bottom. But for a 10-week master's module, this is what I would consider going from I know a bit of Python to I can work as a professional software engineer. This is what is covered in the module, and it's very practical. It involves a lot of the students doing work on their laptops on their own, not people talking, or one person talking like I'm doing right now. I also do some community building, and we provide some training. This is a UCL-wide thing. You will see Jonas, who was mentioned in one of the talks on the first sessions, who was also a co-organizer of me, and there's actually a monthly seminar that I'm unfortunately missing today at 1, if anyone wants to do a Zoom watch of the UCL monthly seminar and has not had enough of image analysis after 4 days. You can join me. So here we do monthly seminars. We give a platform to early career researchers to share their work. We intentionally invite people from different computational and biological backgrounds or different imaging methods to speak at the same event, so we make these connections. And then once a year we run this, and this is kind of similar to the things that was run before. So we have people with lots of varied backgrounds, and so we have 2 tracks. The first track is the first row here. So we do a Python software carpentry, and then a microscopy novice thing, which I will mention later as well, which is a carpentry style introduction to image analysis. And if you think that's too easy, then you can go to Jonas's course, which is Jupyter notebooks for image analysis, and he talks a lot about data types and filters and stuff like that in a Jupyter notebook. And then the thing that I teach, apart from organizing this, is like my very condensed version of the master's module, which is I make you write one test and then make a pull request for that. I make you write one doc string and then you make a pull request for that. So you get some of the software development lifecycle, and you get to have an idea that tests and documentation exists for code. And then the community building aspect that was also mentioned before. We do a full day hack day where people come with their own data, their own ideas, and people self-organize into groups to do something. And that's a lot of fun. It's inspired by another community that I'm a part of, the Software Sustainability Institute, kind of related community in the UK. And so, yeah, this is what I teach at that hack day and training event together. I also have a role where I try to fulfill the magic equation of going from a whole brain image and wrapping some neuroanatomical context around the scientific Python ecosystem to make nice data analysis and visualization. As part of this role, I have some teaching responsibilities for the new PhD students that will likely do some image analysis in their PhD. And here we have lots of software courses. Currently, there's this electrophysiological analysis, or maybe it's finished. It was yesterday. And so we have lots of courses on here, including some image analysis ones. And we also teach specifically our tools, which we can help with, which are linked here. You can see all the slides, everything is public, so we can do some things there. And also there's this microscopy novice, which is, was led by Kimberly Michan, who is a colleague of mine, and this is so while this was going on, I sent Kimberly a message whether she wants to come to the hackathon in April, because this is the software carpentry style introduction to image analysis that exists, and it goes through all of the things as well. So maybe this can help converge, make this courses converge. Cool. And so here in my collaborative coding good practice course, the only thing this was shortened this year, so I had 1 hour and a half. So the only thing I taught them is how to package a Python, to make a Python package, because that helps if I have to condense it even more than 10 weeks. I think packaging is the most important thing, because if they package their code, it's easier to add a test, it's easier to add documentation, it's easier to add other things. So that's where I started from. This. So yeah, I don't know. These are kind of my discussion points and my perspective. I think a lot of them are similar to what I was seeing before. Depending on where you come from, the basics are different. It's all very hands-on, so it's important that the courses are hands-on. There's always more to learn, and we should try to reuse and adapt. And I have a little question with an asterisk, because I have an ulterior motive that I'm not allowed to share publicly. But if you want to answer that question, what should microscopy core staff learn about software? That would be very helpful. I'd be very interested in your answers. And thank you for listening.